Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution. Today we will learn how to solve a pair of linear equations in two variables using the elimination method. I have selected 8 different questions, each representing a slightly different type, so that you understand how to apply this method in various situations. Let us learn the elimination process using this simple example. First, I'll rearrange the second equation so that variables appear in the same order as that of the first equation. That helps us keep things organized. So, we will write 8x first plus 7y equal to 16. Mark the first equation 1 and this equation 2. Remember, in the elimination method, our goal is to make the coefficients of one variable equal so that we can eliminate it. Here, if you see, coefficient of x are 11 and 8 and coefficient of y are 25 and 7. So, we can choose either x or y. The choice is completely to us. Here, I'll eliminate x. So, coefficients, I'll take the LCM of the coefficients. So LCM of 11 and 8 is 88. Now I want to make the coefficient of x 88 in both the equations. So I'll multiply equation 1 with 8 and equation 2 with 11. Do not forget to multiply each and every term by the number you have selected. So 8, so that makes the equation 1. And equation 2 when multiplying with 11 becomes, after this point we either add or subtract the two equations we have got to eliminate x. In this case we see if we add, x is not getting eliminated, but if we subtract, yes. So since we have to subtract over here, we will change the sign throughout. So we get, this gets cancelled because 88 minus 88 is 0x. So this gets cancelled. 200 minus 77 is 123y equals to, so this two same sign means we have to add them up. So we get minus 984, right? Yeah. So the value of y is, y becomes minus 984, divide 123 and we can cancel all of them by, I guess, 8. Right? So y's value is minus 8. Now once we have got the value of y, we will substitute the value of y in any one of this equation to get the value of x. So let's choose equation 2. We have 8x plus 7 into minus 8 equal to 16. Right? So 8x minus 56 equal to 16. 56 goes that side, so 8x equal to 16 plus 56. So that gives me 72. So x is equals to 9. So I hope you have understood how do we use elimination method to solve the system of linear equations. Now let us see another example. This is the second question. The first thing we notice is that this equation, both of these equations contain fractions, and working with fractions can make calculations messy. So it is usually better to eliminate the denominators first. So for the first equation, the denominators are 6 and 15. We take LCM of 6 and 15, which is in this case 30. And we multiply the entire equation by 30 on both sides. So we will get, and now we can easily cancel. So the entire equation becomes 5x plus 2y equals to 120. And this is our equation number 1. Now look at the second equation. Here the denominators are 3, 12 and 4. And LCM of 3, 12, 4 is 12. So we multiply the entire equation by 12 on both sides. So we get, let's cancel first. So we have 4x minus y equal to 19 into 3 is 57, and that becomes our equation 2. Now we can apply the elimination method. So first we have to choose the variable. At this point we can choose either x or y to eliminate. But notice something interesting. The coefficients of y already have opposite signs, plus 2y and minus y. This actually gives us an advantage because when signs are opposite, we can eliminate the variable simply by adding the equations after making the coefficients equal. So eliminating will require less work. We don't have to change the sign of the second expression, remember? So that is why I'll choose y. Of course, you could still eliminate x, but that would require multiplying first equation by 4, second equation by 5, and then changing signs because coefficient of x has same sign in both the equation. So that makes the process slightly long. So whenever possible, choose the variable that makes the elimination easier. So equation 1, so LCM of the coefficients of y, that is 1 and 2, is 2. Equation y already has 2, so I need not multiply anything with equation 1, so I'm writing 1. But with equation 2, I'm multiplying it with 2. So now we have first equation as it is, while the second equation gets multiplied by 2. So we have 8x minus 2y equals to 114. Now you can see 2y, and here 2y gets eliminated easily without having to change the sign. So we are just adding it up. 5 plus 8 is 13x equals to 234, right? So that gives me x equal to, now easily we can cancel here 13 and 8. So x is equal to 18. Now we'll substitute x equal to 18 in any one of the equation given. For simple process, I'll choose equation 2. So I'll put x equal to 18. We have so 18 times 4 is 62, and this 57 comes to the left hand side, so minus 57, and y goes to the right hand side, so equals to y. So y is basically 62 minus 57, which is, I'm so sorry, it will be 72. My bad. So 72 minus 57, which is equal to 15. So the solution for this given pair of linear equation is x equal to 18 and y equals to 15. Now let's move on to a slightly more challenging question. In this problem, instead of just numbers, we also have parameters m, n appearing in these equations. But don't worry, we'll treat m and n just like constant. Okay, so we'll solve this using elimination method just like before. First, let's decide which variable would be easier to eliminate here. So we have x plus y equal to 2m. So we can see coefficients of both x and y are 1 in this equation, right? So which makes it easier to manipulate. Now since the first equation already contains ny minus ny, and here we have opposite sign plus y, so I'm going to choose variable y for elimination, right? So equation 1 remains as it is. So we are not multiplying with anything. So just for the sake, I'm writing multiply by 1. It doesn't make any difference, right? And equation 2, I'm multiplying with n. So let us just copy the equation 1. M square plus n square. And equation 2 becomes nx plus ny equals to 2m into n, 2mn. Now it's very easy to identify and see whether we have to add or subtract. Obviously add, because this 2 simply gets cancelled. So here we have x common, and we have m plus n into x, which is equals to m square plus n square plus 2mn. Now, does this remind you of any identity? This is basically m plus n whole square. Divide by m plus n. This coefficient comes down. So we have x equals to just 1m plus n. Now we'll substitute this in equation 2. We have, so in place of x I'm putting m plus n, plus y was already there, equals to 2m. So everything goes to the other side. So y is equal to 2m minus m minus n. So that gives me y equals to m minus n. So the solution for this given pair of linear equation is x equal to m plus n and y equals to m minus n. So even though the equations looked complicated because of m, n, the elimination method works exactly the same way, whether we have numbers or the parameters. Now this is our next question. Before applying the elimination method, we should write each equation so that it clearly shows one x term and one y term. In other words, the equation should look like the standard form ax plus by is equal to c, where a and b are the coefficients of x and y. Now look at the second equation. Here the variables are inside the bracket. So to apply the elimination method easily, we need to separate the x and y term. So we will distribute a plus b and we write this as this. Now the equation clearly shows one x term and one y term, which makes it easy to compare the coefficient with the first equation and proceed with elimination. Now look carefully. First equation has a plus b into y. Second equation also has a plus b into y. Since the coefficients of y are already equal, it becomes very convenient to eliminate y using the elimination method. And we don't need to multiply anything over here with any of the equation, right? Already the coefficients are same. So I'm quickly writing down the equation once again so that we can proceed with the calculations. Here, while writing a square plus b square term, I'm making sure that I'm writing similar terms together, like a square, b square and b square. Okay, arrange them carefully. Now, obviously we have to change the sign, then only this y variable will be eliminated. So we have to change the sign throughout. So this becomes minus and this also becomes minus. So a plus b minus a plus b gets cancelled because same thing, opposite sign. And over here a minus a becomes 0. Minus b. So minus 2bx. A square minus a square 0. Minus 2ab and minus 2b square. Right? So x equal to this minus 2b will obviously go in the denominator here. And here I'll take minus 2b common. So I'm left with a plus b. So we cancel this entire term. So we get x equal to a plus b. Now you know our next step. We'll put x equal to a plus b in any one of the equation to find out the value of the other variable. In equation 1, we have a minus b into a plus b plus a plus b into y equals to a square minus 2ab minus b square. So here we are getting a square minus b square. Remember the identity a minus b into a plus b equal to a square minus b square. A plus b into y gives me a square minus 2ab minus b square. Now plus a square gets cancelled, minus b square gets cancelled. So y is equal to minus 2ab by a plus b. That's it. So the solution for this system of linear equation is x equal to a plus b while y equals to minus 2ab by a plus b. Now this is our next problem. First of all, I'd like to bring all the constants to the right hand side. Okay. So I'll write the equations as this. Now this is my equation number 1 and equation 2 becomes Now again over here I choose variable y whose coefficients I'll make same. So here we have ay and but I have a b over here in the denominator. So what will I do? I will divide each term of equation 2 by b. So that means first term by b, second term by b, and this term by b. Okay, so if I do that, obviously over here bb gets cancelled, here also bb gets cancelled. So equation 1 remains as it is, and equation 2 becomes x minus ay by b equals to minus 2a. So I'll write under a only. Remember, we write everything, all similar terms, like terms together, right? Now, obviously, I need to change my sign over here if I want to cancel y. So this becomes plus, this becomes minus, and this one becomes plus. So this part gets cancelled. Now over here, I have b by a coefficient. Here I have 1. So b by a minus 1, and the variable is x, equals to 2a minus a, which is a, and minus b comes down. Now, here if I solve, I get this. Now let's solve further. So obviously a will move up. So x equal to, and here I'm taking minus common. So I'm left with b minus a into x divided by b minus a. I'm so sorry. This will be a. So now b minus a gets cancelled. So x is equal to minus a. Now the next step. So here I'll choose obviously the second equation, equation 2. So in place of x, I'll put minus a. So this part becomes minus ab, right? And minus ay is equal to minus 2ab. I've sent this part over here. And minus ab goes that side, so it becomes plus ab. So that gives me minus ay is equal to minus ab, right? Minus 2ab plus ab is minus ab. AA gets cancelled from both sides. So y is equal to just b. So we have the solution. X is equal to minus a and y is equal to b. Now let's look at another type of question where the variables appear in the denominator. Now at first this may look complicated, but notice that the fractions have 2 in the denominator, right? So either you can do, let me mark this equation 1 and equation 2. You can multiply this one with 2 or this one with 2. Now again we have the coefficient of y has different sign, opposite sign. So let me eliminate y, and for that what will I do? I'll multiply equation 2 by 2. Why? Because if I do so, have a look. If I multiply each term by 2, this 2 and this 2 gets cancelled. So I have 1 by y, which is same as that of our first equation. And hence, we can eliminate that easily. So let's do it. So equation 1, I'm doing nothing. So just for the sake, I'm writing multiplied by 1. And equation 2, I'm multiplying by 2. So equation 1 remains as it is, while equation 2 becomes 2 by x plus 1 by y equals to 16. Do you notice how we have multiplied? So 2 ones are 2 and this 2 gets cancelled, so 1 by y, and this becomes 16. Now obviously we'll add over here because these two already has opposite sign. So easily it will get cancelled, and here 1 by 2x plus 2 by x equals to 16 minus 1 is 15. Now what is the LCM of 2x and x? It's 2x, right? So over here, to make the denominator same, I need to multiply 2 in the numerator as well as denominator. So I get 1 plus 4, which is equals to 15. Now let's take reciprocal on both sides. So we have 2x by 5, because 4 plus 1 is 5, equals to, now this side reciprocal will give me 1 by 15, right? So x is equals to 1 by 15 into 5 by 2. So that means x is 1 by 6. Now, using this value, we'll find out value of y. So, you can choose any of this equation. Let me go with 1. So, putting x equal to 1 by 6 in equation 1. Now, if you notice, if x is equal to 1 by 6, which means 1 by x is equals to 6 by 1, I've just taken reciprocal on both sides. Now I need 1 by 2x, right? So for that I need to multiply 2 in the denominator on both sides. So I am getting 1 by 2x is equal to 3. So in place of 1 by 2x, I'll write 3 minus 1 by y is equal to minus 1. So that gives me 3 plus 1, this one comes this side, and this part goes that side, equals to plus 1 by y. So that gives me 4 equals to 1 by y. So y is equal to 1 by 4. Again taking reciprocal on both sides. So 4 by 1 becomes 1 by 4 and 1 by y becomes y. So finally our answer, this is the solution for this given system of linear equation. Now an alternative method would be to substitute 1 by x and 1 by y. So let me say let 1 by x equals to a and 1 by y equals to b. So if 1 by x becomes a, so my equation becomes a by 2 minus b equal to minus 1. And the second equation becomes a plus, now in place of 1 by y, again I'll put b. So b by 2, because 2 was in the denominator. Be very careful. Equals to 8. Now the question becomes exactly like question number 2. Remember fractional coefficients. And if you don't like fractions, so what are you going to do? Take LCM of the denominator. Here denominator is only 2 throughout. So we multiply both sides by 2 just to get rid of the denominator. And it becomes 2 into a by 2, which is a, minus 2b equal to minus 2. And the second equation same. LCM of the denominators will be 2. So I am multiplying with 2 on both sides. So we are getting 2a plus b equals to 16. Now this is my equation number 3 and equation number 4. To eliminate this, you can multiply equation 4 with 2 and eliminate b. Find a, put the value of a either in third equation or in fourth equation, then you will get the values of a and b. But don't forget to come back to x, because finally you have to find the value of x, right? So in place of a, just put 1 by x equals to whatever you have got. In place of b, 1 by y equals to whatever you have got. Take reciprocal on both sides, so you'll get the value of x and the value of y. And that will give you the solution of this system of linear equation. So this is another method. Now let us try one more question of slightly different type. Now look carefully at this pair of equations. Before jumping into calculations, it's always a good idea to observe the structure of the equation. Notice something interesting. The coefficients 55 and 67 are interchanged. In the first equation we have 55x plus 67y, and in the second equation we have 67x plus 55y. Because of this pattern, we can use a smart strategy. First, let us add these two equations. So if I add these two equations, I'll get 55x plus 67x. That's 122x. And same numbers we're adding over here, 122y equal to 610. So we'll factor out 122. And now we can cancel 122 by 5. 122 5 times is 610. So we have our first simple equation. Next step is to subtract the equations, equation 1 and 2. Now obviously to subtract we have to change the sign throughout, right? So 55 minus 67 is minus 12x plus 12y equals to 12 again. So here we are taking minus 12 common. So I'm left with x minus y equals to 12. And that gives me x minus y equals to minus 1. So this is our next simple equation. Now we will solve these two equations, 3 and 4. No need of changing sign over here. Y gets cancelled anyway, plus y minus y. And x plus x is 2x equal to 5 minus 1 is 4. So x is equals to 2. Now obviously I'll put equation 3 or 4. So equation 3. So we have 2 plus y equals to 5. So y is equal to 5 minus 2, which is 3. So the solution for this given system of linear equation is x equal to 2 and y equals to 3. The important idea to notice in this question is the pattern in the coefficient. Since the coefficient of x and y were interchanged, adding and subtracting the equations helped us quickly find the values of x plus y and x minus y, which made the problem much easier to solve. So whenever you see this type of pattern in a question, try this approach. It can save a lot of time. Now let's move on to another example. Now let's look at our final question, which is slightly different from the previous ones because here the variables appear in the exponent. At first this might look complicated, but we can simplify it by expressing the powers in terms of 2 to the power x and 3 to the power y. What I want to say is, notice that 2 to the power x plus 2 can be written as 2 to the power x into 2 square, right? Minus 3 to the power y plus 1 can be written as 3 to the power y into 3 to the power 1. Remember laws of exponents? A to the power m plus n is equal to a to the power m into a to the power n. So over here my base is 2. So 2 to the power x into 2 square. So we get 4 into 2 to the power x minus 3 into 3 to the power y and equals to 5. Now at this point, it will be helpful if I take let 2 to the power x equals to a and 3 to the power y equals to b. So our equation becomes a plus b equal to 17 and 4a minus 3b equals to 5. Let's mark the first one equation 1 and this one equation 2. Now we'll apply same elimination method. Obviously, I'll choose B over here. Now you know why. I'll multiply equation 1 by 3 and equation 2 by nothing. That is 1. So my equation 1 becomes 3a plus 3b equals to 51. And equation 1 remains as it is. And here we are going to add. So 7a is equal to 56. So that gives me a equals to 8, right? 7 8s are 56. So putting a equals to 8, obviously I'll choose equation 1. We will get b as 17 minus 8, so which is 9. Now we have to find the values of x and y. So I have now a equals to 8. So a was 2 to the power x, so 2 to the power x is equal to 8 is 2 to the power 3. So if the base are same, powers will also be same. So x is equal to 3. And we have b equals to 9. What was b? b was 3 to the power y. So 3 to the power y, 9 is 3 square. So that implies y is equal to 3. So solution for this system of linear equation is x is equal to 3 and y equals to, so sorry, I made a mistake over here. Y should be equals to 2, right? So y is equal to 2 is the solution for this system of linear equation. Alright, with this we have explored several different types of problem using the elimination method. Try practicing a few similar questions on your own to strengthen the concept. I'll see you in the next video. Thank you for learning with me. I'll see you in the next chapter. And oh yes, if you're finding these lessons useful, you can support the channel by liking the video and subscribing. Bye-bye.